Mr. Ling here. I just wanted to do a quick video on lesson 2.07 because it seemed like a few people were maybe struggling with this one a little bit, and this has some really important concepts for not only math and algebra, but also science that you'll come across later, and especially when you get into chemistry. So let's go through a couple of these problems, and I want you to think about what we're doing here. So this first problem, and this I actually can go into the analytics for the assignment, and I can see where a lot of people missed. And this is one that basically everyone got wrong. So I wanted to go over it first. So this question is asking the formula V equals IR shows the relationship between voltage, current, and resistance. These are electrical things. So this is going to be something you deal with in physics, actually. So we want to solve this for the formula R. Now, I want you to think about this. All we're doing with these literal equations is we are just isolating our variable. We're getting our variable all by itself, just like we do when we solve for x in a regular equation, one variable equation. So in this case, we're not going to get an answer in any kind of numerical values because we don't really have any, but we're going to show what our answer would be if we knew what the other variables were, okay? So in this case, we want to find out what R is, okay? So I wrote the equation over here, V equals IR, and get rid of that thing there. So again, all we're doing is we're trying to isolate our variable. Now, I just want you to remember, anytime you see two variables right next to each other like this, that means that there is a little tiny multiplication symbol right there, okay? It means you're multiplying those, all right? So in this case, we want to solve for R, right? So I'm just going to write that there, solve for R, okay. So in this case, what we need to do to get R by itself, well, if this is I times R, the opposite action there for multiplication would be division. So we would need to divide both sides by I, right? So we get rid of I on this side, and this is the I is underneath the V on this side. Basically, we're just dividing, right? So these cancel out. We're left with R on top. I'm just going to bring this down here. And this would mean then that V over I equals R, okay? And this, of course, can be written backwards due to the reflexive property of equality, because I always like to have my variables on the left, all right? So there you go, R equals V over I. We're just isolating that R, okay? Just like we do otherwise. And this answer here, it says R equals V divided by I. So I just wanted to make sure that that didn't throw some people off. V divided by I is this. This is the same thing as saying V divided by I, right? Anytime you see the numerator over the denominator, it's just a fraction, and any fraction is really the top number divided by the bottom number, okay? So V divided by I looks like this, V over I. Okay, let's do another one. So this one down here, this is now an inequality that we're dealing with. So we want to solve the inequality. T is greater than L plus D, all divided by B. And we're solving for D. It's kind of crowded up here. Okay, so let's write this out. What does this look like? T is greater than L plus D. Okay, let's start there. I'm just going to go to the next page here. T is greater than L plus D, right? We have it so far. T is greater than L plus D, all divided by B, all right? So this is L plus D, all divided by B. So L plus D, all divided by B, right? That just means it's all over B. Divided by is just this line across there. All right, so I think that's our equation. T is greater than L plus D, all divided by B, and we're solving for D, okay? So I'm just going to write this here. I'll write it on this side so it's not in the way. Solve for D. All right, so D is right here on the top. Let's write this in another color so we can kind of highlight it. So this is what we're trying to get all by itself, right? So the first thing I see is we want to get rid of this denominator down here. I just don't like fractions. I think a lot of you don't either. So the best way to do this is if we take this whole side and if we multiply it by, use a different color, we multiply that by b, right? Okay, and again, this is just anytime you have a whole number, we're going to call b a whole number here. You put it over a 1, right, if you're multiplying fractions together. So you get b times d times L. Okay, I'm going to write this all out here just so you see what I'm talking about. Well, let's see. Actually, we have to distribute this, don't we? Because this is saying b times this whole thing right here. So we have to distribute this b times the d and b times the L. So we would end up with BL plus b times d, right? And then the 1 times the b, we just get b. And then we can see that the b's will cancel out. And I could have canceled this before. I could have canceled this right here, right when I started multiplying this. I could say, well, we're just going to cancel that, okay? Because again, b over b, if you're multiplying those fractions together, b over b is just 1. You can do the same thing here. You can kind of distribute the division, just like you distributed this multiplication up here. You said b times everything inside here. This is b divided by both of these terms right here. I'm just going to underline those in a different color. So these terms here, right, goes into both. So you can cross those out. Those actually cross cancel. All right, that cross cancels with everything. And again, we have to do the same thing on the left side, right? So we have b times t. All right, so let's write it all down here. What are we left with? We're left with b times t is greater than, and we haven't divided by anything or multiplied by any negative number, so our inequality stays the same. And what are we left with down here? L plus d, that's all that's left. L and d, and this plus sign right there, that's all that's left. So it's just bt is greater than L plus d. Now we're solving for d, right? So to get d all by itself now, this is just a plus, right? So we can just subtract L from both sides. Actually, let me do a different color here. We just subtract L from both sides. Subtract L, subtract L. I'm going to put this over here now. And we get B, go away. There we go. BT minus L is greater than D. Okay? Another way of saying that is D, because I like my variables on the left, we're solving for D, right? D is, now I'm switching it, so I got to switch the sign, less than BT minus L. Okay? And let's see if we're right here. The right answer is D is less than, well, this is TB, but same thing as BT. Again, the commutative property of multiplication there. You can go in any order when you're multiplying. So BT minus L greater than D. And this is basically the same thing as this, just with the B and the T switched. So we got it. Good. All right. One last one. More practice, the better, right? This is a long one, so I thought this would be a good one. So this one we want to solve for n. And as we got a long inequality here. 21k minus 3n. I'm just going to write it down as we talk. 21k minus 3n. 21k minus 3n plus 9p is greater than, 3p plus 12. 3p plus 12. I can barely fit that in there. All right. Well, as you can see, we've got a few different, we've got some p's here, and we could combine, right? We've got an n and a k. We can't combine any other like terms. And we got a number all by itself here, 12. But we can combine these p's. So in this case, we're solving for n. I'm going to write that there. Solve for n. Okay. So we want n. I want to keep n on the left. So I'm going to bring this p over here. Best way to do that, it's a positive 3p on this side, so you do the opposite operation. So we're going to subtract 3p from that side, subtract 3p from that side. These will cancel. We're left with, go back to blue again. Red seems so angry. 21k minus 3n. 9 minus 3 is plus 6p. So greater than, what's left over here is just 12. Okay? Now, so let's get our n all by itself. I'm going to write n into a different color so we can help see how we need to isolate it. All right. So next thing we're going to want to do is, well, let's get this 21k out of here. So let's subtract this 21k. Okay, we're going to subtract that from both sides. Oops, 21k. We can do two steps at the same time. Why not? You guys are getting good at this. Let's save some time. Let's also get rid of the 6p in the same step. Subtract 6p, and I'm going to subtract 6p. I'm just kind of doing it down because I'm running out of room there. And after doing this, this is going to cancel. We're going to have negative 3n. This is going to cancel. Greater than, we haven't multiplied or divided by anything negative. I'm just going to leave the 12 there. Minus 21k minus 6p. Okay? Now, the only thing we have left to do to get rid of this n is, you guessed it, this is negative 3 times n, so we have to divide this side by negative 3. Oops, now watch out, we're dividing by a negative number here, right? Put an arrow there. And we're going to divide this whole thing, this whole side. We have to do the same thing for both sides. Negative 3. And what's going to happen with the sign? It's going to flip, right? It's going to flip. All right, so let's move this whole thing over here now. And let's go back to blue. I'm liking the blue better. We have, because this is going to cancel, we have n is now less than 12 minus 21k minus 6p all over 3. Are we done? No, we're not. We can simplify this, can't we? We can distribute this 3 by division. This 3 can go into, let me do this in a different color again. I'll do it in orange. This 3 can divide into that. This 3 can divide into that. And that 3 can divide into that. Luckily, in this case, it can divide evenly. If it wouldn't divide evenly, it would be best to leave it like this. But it can divide into each number evenly. So let's go back now. N is less than 12 divided by 3 is 4. 21 divided by 3 is 7. And there's a negative there, so it's going to be negative 7k. Can't divide the k, so it's got to stay there. 6 divided by 3 is 2, and there's a negative sign there, so it's going to be negative 2, and the p stays. And that's about as far as we can go. So let's see if we did that one right. 4 minus 7k minus 2p. The right answer is 2p plus 7k minus 4. So I did something wrong. Let's see if we can figure out what I did wrong here. We ended up with, oh, I see what we did wrong. I see what we did. Do you see what I missed? Do you see what I missed? This is a good learning moment. That's why it's okay to make mistakes, even for a teacher. It's a good time to learn. Notice, if you didn't catch it already, this is a negative. When I moved it over here, I forgot the negative sign. Oops. So, if it's a negative, that's going to change every sign now, right? Because now it's going to be 12 divided by negative 3, which is going to make that a negative 4. Negative 21 divided by negative 3, that's negative divided by negative, so this is positive 7k. And negative 6p divided by negative 3, again, negative divided by negative is positive 2p. So that's what I did wrong. Now, let me see if we're right. The answer was 2p plus 7k minus 4. 2p plus 7k minus 4. I can rewrite that the same way. So using the commutative property of addition here, I can say this is 2p plus 7k minus 4. Haven't changed anything in that. All right, I know this was long, but I hope this was helpful.